In this video, we're going to put everything we've learned together. We're going to look at proofs. Some will be fill in the blanks, some will be not. We ought to be able to start recognizing by now, if they're not fill in the blanks, how to create a proof step by step using the things we know about parallel lines. We also need to make sure we know the difference between the corresponding angles theorem and the converse of the corresponding angles theorem. And similarly, alternate interior angles, alternate exterior angles, and same side or consecutive interior angles theorems. So it's important that we know that if we're trying to prove that angles are congruent, meaning that we already know the lines are parallel, say in this example, if we knew these lines are parallel, we could say 2 is congruent to 6. That's corresponding angles theorem. If we're trying to prove the lines are parallel and we know that the angles are congruent to start with, we use the converse. So we're going to look at some proofs where we use both of those, and it's important we pay attention to those. This first one is actually proving the perpendicular transversal theorem. We looked at that a couple videos ago. The perpendicular transversal theorem says if one line is if a line is perpendicular to parallel lines, then it must be perpendicular to both lines. In this example, we are shown that H and K are parallel. We are told that J is perpendicular to H, and we're asked to prove that J is perpendicular to K. Now this is the perpendicular transversal theorem, so we cannot use that reason in our proof, but in the future, if you're asked to show something where this is handy, you can use this theorem as one of your reasons. If we look at our proof, it has some fill in the blanks we're going to fill in. We always start with our given as our first step, so we're going to list that H is parallel to K and J is perpendicular to H. We should recognize the notation on both of those. This means parallel, this means perpendicular, and that was our given. Step 2 says the measure of angle 2 equals 90 degrees. If we look here, we have J is perpendicular to H. We have that shown here in our diagram. That's our definition of perpendicular, or, sorry, we have a right angle shown here. Perpendicular lines meet at a right angle, but since this is a right angle, we're going to say definition of a right angle. Specifically, angle 2 we're shown here as a right angle, so we know its measure is 90 degrees. Step number 3 says corresponding angles theorem. Well, we have lots of pairs of corresponding angles. We have angles 1 and 5, 2 and 6, 3 and 7, and 4 and 8. We're trying to figure out which ones are going to help us out. I would use the rest of your proof to help you with that. If we look, the next step is 2 and 6. So I would look and see our 2 and 6 corresponding angles, and they are. So it would probably make the most sense to use 2 and 6 for our corresponding angles theorem, because now we can say step 4, because we know the angles are congruent, we know their measures are equal. That's the definition of congruent angles. So now we have the transitive property. They said the measure of angle 2 equals 90, the measure of angle 2 equals the measure of angle 6, therefore the measure of angle 6 equals 90 degrees. That's the transitive property. And our definition of perpendicular lines, if two lines meet at a 90 degree angle, that's a right angle, then these two lines are perpendicular. That was what we were trying to prove. J is perpendicular to K. So there's our first proof. If we look at the next example, we have angles 1 and 2 are congruent. I'm going to go ahead and mark that here in our diagram. We also are told that angles 3 and 4 are congruent. So this angle is congruent to this angle here. And we're asked to prove that these two lines are parallel. So AB is parallel to CD. We're trying to show that these two are parallel. We don't know that yet. Well, if we think about some things we know, well, let's first start with writing our given. Sorry, we're always going to start with our given. And you can choose if you want to write these on two separate lines or one line together. But since they're both our givens, I'd say let's just write them together. If we look at our picture, we know that angles 2 and 3 are vertical angles. They're both congruent there because we know that all vertical angles are congruent. The vertical angles congruence theorem tells us that all vertical angles are congruent. Well, now we can start substituting in here and say, okay, well, angle 1 is congruent to angle 2, so we could substitute in angle 1 here, or really that's even the transitive property. And angle 3 is congruent to angle 4. So we can put in here angle 4, and we just switch those out because they're both equal to the same, or both congruent to the same thing. They're both congruent to each other. I'm going to say transitive property here. We use substitution if there's an equal sign. This isn't an equal sign, so we're going to say transitive property. We could actually write that step out twice if you wanted to say angle 2 is congruent to angle 4, using the transitive property here, and then switching these out. Angle 1 is congruent to angle 4. But if we have the same reason for step, we're allowed to do 2 steps at the same time. So we just use the transitive property there twice. And because now we've shown that angle 1 and 4 are congruent, then we know that these lines are parallel. I should have mentioned that before we got started. But if we look, we should be able to recognize what type of angles those are. If it helps, extend these lines. We're trying to show that these are parallel lines. So here's one line, and here's our transversal. Do we see there's a relationship with these two lines? If we look, draw yourself another picture if it helps you out. We're looking at this angle, we're looking at this angle. We should be able to recognize that those are alternate interior angles. So if we know the lines are parallel, we know alternate interior angles are congruent. If we can show alternate interior angles are congruent, which is what we've just done, then that proves by the converse of the alternate interior angles theorem that the lines are parallel. So again, if we're trying to show lines are parallel, we're going to use one of our converse theorems. If we're trying to show angles are congruent, we're going to use one of the original theorems we learned. All right, let's look at these last two. Given line A and B are parallel, so I'm going to go ahead and draw that in our diagram to help us remember, and angle 2 and 3 are congruent. We're asked to prove C and D are parallel. Because we're asked to prove C and D are parallel, we should know that we're going to end up using the converse of one of our theorems to help us do that. We don't know which theorem yet, but we know it's going to be a converse. I just wrote that there to help remind us. So if we look, converse of one of our theorems tell that these lines are parallel. Well, if we look, 1 and 2 are corresponding angles. We could use the converse of the corresponding angles theorem if we can show that 1 and 2 are congruent. So let's see if we can make that work out so that 1 and 2 are congruent as our last step. We start with what we're given. We're given A and B are parallel. That was our given. And we're going to look at what else we know. Well, if these are parallel lines, we can look at these at either transversal. These two are same side interior angles. Or we could look at these two parallel lines. I'll mark them parallel over here again, cut by this transversal. Well, I like this option better because I know that angle 1 and 3 are alternate interior angles. I know that alternate interior angles are always congruent whenever I have parallel lines. So the alternate interior angles theorem tells me that those angles are congruent. Well, if we look, we're trying to get to 1 and 2. We know that let's see, we know that 2 is congruent to 3, we know that 1 is congruent to 3. That must mean that 2 is congruent to angle 1. That's our transitive property of congruence again. So we use transitive property if we're talking about if we're talking about congruence. We use substitution if we're talking about equality. So pay attention to that as you're working on recognizing those. We only substitute things in if they're equal for each other. Well, we said we were trying to show that 2 and 1 are congruent because we know those are corresponding angles. If we have corresponding angles congruent, the converse of the corresponding angles theorem tells us our lines are parallel. In this example, C and D are lines that are parallel because the corresponding angles are congruent. All right, last example. Notice here we're asked to show that these two angles are congruent to each other, not parallel. So we're not going to use a converse, we're going to use one of our original theorems we learned, corresponding angles, alternate interior, alternate exterior, same side interior angles. We're also going to use some other things we've learned. If we look here, we have 3 lines. We are given to start with that J is parallel to K, and that K is parallel to L, and that's our given. And we have a property we learned that says if 2 lines are parallel to the same line, they must be parallel to each other. That's called the transitive property of parallel lines. And just like the other transitive properties we know, if 2 things are equal to the same thing, they're equal to each other. In this case, 2 things are parallel to the same thing, they are parallel to each other. This is called the transitive property of parallel lines. Well, because these 2 lines are parallel, then if we look, we can actually just ignore K. So we could redraw this if it would help us out and just look at, okay, here's angle 1, here's angle 6. What do we notice about those 2 angles? Well, they are called alternate interior angles. The alternate interior angles theorem tells us whenever we have parallel lines, we know that alternate interior angles are always congruent. That's actually what we were trying to prove, so we don't even need this last step. We are done. We have these 2 angles are congruent to each other. Again, because these 2 lines are both parallel to line K, they must be parallel to each other. Because they are parallel, angles 1 and 6 are congruent. That's the alternate interior angles theorem. So look over these. Make sure you know the difference between when you use a converse, when you use theorem, what other theorems you might use, like the transitive property of parallel lines, perpendicular transversal theorem, linear pairs postulate, vertical angles congruence theorem. We have a lot of these we ought to be able to recall now.